So let's continue with section 2.1. We're on 2.1b as in boy, and we're on page 182 of chapter 2, and we're talking about simple interest. So if you remember from a long time ago, simple interest looks like that, I equals PRT, where I is the amount of interest you made on money you invested, principal, times the rate times the time. So what we've got here is your principal. Let's say that you put $100 in savings and it was at 5% interest for 2 years. Okay, so there's your P, there's your R, and there's your T. And the answer that you're going to get is how much interest you made on this $100. So let's say you put it in there at 5% for 2 years, and let's say that you ended up making $10. At the end of 10 years, you made $10 interest. That is your I. Then if we take your amount that you invested, 100, now you have $110. But the I here, this I here, does not represent the amount you invested plus the interest. It's only the interest. You're going to have to add your principal to find out how much money you actually have now. So anyway, that is I equals PRT. So we're going to look at example 6. So we've got Jared, he's got 2 student loans, and when you add both of those student loans up, loan 1 plus loan 2, you get $12,000. That's how much he borrowed. Alright, one loan is 5%, the other loan was 8%. So both of those loans added up to be $12,000. One was 5%, one was 8%. After a year, he owes $750 in interest. That means that after a year, after this T is 1 year, when you take P times R times 1 year, you're going to get interest, and that interest is $750. So we're going to put I equals $750 up here. That's how much money he was going to owe in just interest besides the $12,000 that he borrowed. Okay, so let's go ahead and make a table and go from there. Okay, so there's my table. I'm going to look at this row here with my money invested at 5% and this row with my money invested at 8%. So across the top we need to do our PRT. So we're going to use this as my principal. We're going to use this as my interest rate. This is my time. And this as my I, because that's what I'm trying to find. So my principal at 5%, I have no idea, because that's one of the things I'm looking for. And my principal at 8%, I have no idea. So we're going to call one X. So let's just call the first one X. The second one is going to be the amount I borrowed minus X. Okay, so when we take the 8% and the 12% and add, or 5% and add them together, we should get the total amount we borrowed. So since we don't know what that is, we're just going to call one, and the other one is our total minus this one, and that'll give us this, how much we have here. Our rate then, we said was 5% here, so we're going to put that as 0.5. And our 8% we're going to write as 0.08. And the time period we're looking at is 1 year for both of those. And now I know my interest, according to this, is PRT. 0.05 times X times 1. Okay, I just put the rate first instead of the principal because it wasn't a variable. And for the next one, I have 0.08 times 12,000 minus X times 1 year. Okay, I know that these two aren't necessarily equal. I mean, I don't know that they are equal or aren't equal, but I can't say they are. But I do know that when I take the principal, the interest that I made, or that I have to pay on this loan, and add it to the principal I have here, it's going to equal the total interest, because that's what it said, is the total interest was $750. So if I take 0.05x and add 0.08 times 12,000 minus x, and I add those two together, I'm going to get $750. So I'll leave the math up to you to go ahead and solve that. But a good handy calculator will give you an answer pretty quick and easy that x equals 7,000. So that's how much I borrowed at 5% interest. So therefore, the amount I borrowed at 8% is going to be the 12,000 total minus the 7,000. So the amount at 8,000 will be $5,000, or the amount at 8% will be 5,000. So the last example of story problems has to do with example 7 on page 183. Has to do with soccer fields, and they tell us that we have a soccer field, and that soccer field is 30 yards, the length is 30 yards greater than the width, and the perimeter is 460. Okay, so my width and my length. The length is 30 yards longer than the width. So if my width is W, my length is going to be the width plus 30. Perimeter I know is the, if you add this side, this side, this side, and this side together, we get the perimeter, which in this case is 460. So we're going to take W plus W plus W plus 30 plus W plus 30 equals 30, 460. So I'm going to add all those up, and that'll be the perimeter. So 4 W's plus 60 equals 460. So 4W equals 400. W equals 100. So it's 100 feet or 100 yards wide, and then I add 30 and I get my length there of 130. So that's it as far as that story problem. Pretty quick and easy. This last part on page 184 called the zeros of linear functions. Basically, in that first sentence says it all. An input for which the function's output is 0. So if I can take a number and put it in to the function machine and it spits out a 0, the input that I'm putting in here is what I'm looking for. So again, my input is x, my output is going to be my y value or my f of x value. So if I've got a problem such as x plus 3, and I, in order to get a zero for an answer, okay, so this is important to get. If I want to get a 0 for an answer for my y, what number has to go in here for x? All I have to do is set my equation up like that. X plus 3 equals 0. X equals negative 3. So if I put a negative 3 in my function, it will spit out a 0. And if I were to graph that, it would be this point right here. What will always, always, always happen is when I set any equation to 0, any linear equation to 0, x plus 8 equals 6. If I set that equal to 0, my value that I get x to be will always be the value where it crosses the x-axis. Always, always, always. Because I'm setting my y value equal to 0, I'm saying I want to get as an answer 0. What number do I have to put in for x in order to get that 0? It's called the x-intercept, actually, but there are several names. There's the 0 of the function, there's the x-axis, and then there's the root of the equation, which we haven't started talking about yet, but the root of an equation is also what we're looking for. So anytime an equation is set equal to 0, we're looking for the 0 of the function. What makes x 0? So let's put one up here. 5x minus 9 equals 0. Alright, so it's already set equal to 0. And what I'm finding out here is, I'm just going to solve this algebraically. Okay, what this tells me is where the line of the equation 5x minus 9, where that equation, which let's just draw the graph here real quick. There's the graph. This 9/5 tells me where the line crosses the x-axis. It crosses at 9/5, and my y value is 0. I didn't go up or down any. That's the point where it crosses. But all I'm interested in is the x value, because I know my y value is 0, so I don't even have to list that. I just say it crosses at 9/5, where the 0 of this function is 9/5. That's where the line crosses the x-axis. Okay, so that's it for 2.1.